Connexive logic is a family of non-classical logical systems, at least partly motivated by the idea that there should be a meaningful connection between the antecedent and the consequent of a conditional statement. The term connexive derives from the Latin connexio, meaning connection or linkage. At a very general level, connexive logic aims to rule out conditionals that are true merely for formal reasons, despite an apparent lack of connection between their components. There are different views about what exactly qualifies a logic as connexive. Some authors define connexive logic broadly as any system validating certain anti-paradoxical principles for conditionals, while others take a more restrictive stance. In this introduction, we focus on one of the most common and influential views. According to this view, a logic is connexive if it validates characteristic principles that prohibit conditionals such as if A, then not A, and if not A, then A. The defining principles of connexive logic are usually attributed to Aristotle and Boethius. Two especially important ones are Aristotle's thesis or theses and Boethius's thesis or theses. Intuitively, Aristotle's theses express the idea that nothing implies its own negation, and nothing is implied by its own negation. In classical logic, both theses fail since any false antecedent makes a material conditional true. Connexive logic rejects this feature and demands a stronger link between antecedent and consequent. Intuitively, Boethius's theses express the idea that not both A implies B and A implies not B are true. Some logicians also claim that implication according to connexive logic is non-symmetric. The primary difference between connexive and classical logic concerns the interpretation of the conditional. Classical logic identifies the conditional with material implication, which is false only when the antecedent is true and the consequent false. This makes many conditionals true simply because their antecedents are false, regardless of any intuitive connection. Connexive logic rejects this account. It denies that false antecedents automatically yield true conditionals and blocks inferences that rely on this feature. As a result, many classically valid principles involving implication fail in connexive systems, while others must be reformulated or restricted. Connexive logic is closely related to relevance logic, and the two traditions often overlap. Both aim to ensure that implications reflect a genuine connection between premises and conclusions. However, they are not identical. Relevance logic tends to focus on inference. A valid argument must use its premises in a relevant way. Connexive logic, by contrast, usually focuses on the conditional itself, imposing constraints on which conditionals can be true. Some relevance logics are connexive, but not all connexive logics are relevance logics. The shared motivation is to avoid implication without connection, but the technical implementations can differ. Several motivations underlie the development of connexive logic. One is philosophical. Many have found it deeply counterintuitive that, for example, a sentence like, "If 2 + 2 = 5, then London is in Africa," should be true. Another motivation is historical, stemming from interpretations of Aristotle's views on implication. A further motivation comes from applications in areas such as philosophy of language, ethics, and legal reasoning, where conditionals often presuppose explanatory or normative connections. Connexive logic can thus be seen as an attempt to align formal logic more closely with intuitive and explanatory uses of conditionals. The syntax of connexive logic is typically very similar to that of propositional logic. Formulas are built from propositional variables using familiar connectives, such as negation, conjunction, disjunction, and a conditional. The crucial difference lies not in the syntax itself, but in the axioms or rules governing the conditional. Some systems introduce additional connectives or distinguish between different kinds of implication, but many connexive logics retain a single conditional whose behavior is non-classical. A variety of semantic frameworks have been developed for connexive logic. These include truth-value semantics with more than 2 truth values, relational semantics inspired by relevance logic, and possible world semantics with restrictions on accessibility. In many relational semantics, the truth of a conditional depends on structured relationships between situations or worlds, rather than on a simple truth functional clause. These semantics are designed to ensure that conditionals violating connexive principles come out false, even when their antecedents are false. Logical consequence in connexive logic is typically defined in the familiar semantic way. A conclusion follows from a set of premises if and only if, in every model and every relevant situation where the premises are true, the conclusion is also true. Validity is then defined as truth preservation under all interpretations admitted by the system. Many non-classical logical systems are strictly weaker than classical logic. Connexive logical systems are usually both weaker and stronger than classical logic. This means that connexive logic rejects some principles that are classically valid and accepts some principles that are not classically valid. Similarly, some arguments that are classically valid fail in connexive logic, and vice versa. Systems of connexive logic are therefore sometimes called contra-classical. They are neither subsystems nor extensions of classical logic. Connexive logics admit several kinds of proof systems. These include Hilbert-style axiomatizations validating connexive theses, sequent calculi with restricted implication rules, natural deduction systems designed to block paradoxical conditionals, labeled or relational calculi reflecting semantic constraints. Each proof method offers different insights into how connexive constraints operate at the inferential level. Connexive logic can be extended in various ways. It can be strengthened or weakened by adding or removing axioms, or combined with other logical systems. For example, connexive modal logic study conditionals under necessity and possibility, while connexive deontic logics aim to capture meaningful connections between obligations and conditions. Such combinations expand the expressive power of connexive logic and open the door to practical applications. Many connexive systems are sound and complete with respect to their intended semantics. Some are decidable, while others trade decidability for expressive strength. As with other non-classical logics, metalogical properties vary widely depending on the specific system. Connexive logic represents a sustained attempt to restore a notion of genuine connection to the logical conditional. By rejecting implication without connection, it challenges classical assumptions while remaining firmly within the tradition of formal logic. Whether viewed as a refinement of relevance logic or as a distinct approach to conditionals, connexive logic continues to offer valuable insights into the nature of implication and reasoning.